And I've got Gustafson Custom Ordnance in Adelaide, and thanks for coming. So hopefully I can share some things that I've learned on a journey through metal that will be useful for you. Let's see. It's weird to do a second one and then get like, I got really excited on the first one and started over again. What I'll do, what I'm hoping to do today is I'm going to take you through, the metals that we work with in our shop and failures that happen, ways that we can hopefully correct them, some things we can't do. I want to hear from you guys what problems you've had, and I'll also tell you what problems I've had and how I overcame them. This clinic started in 2004, and I had a tuba player come in with a service, and at the time I didn't have an ultrasonic. I was in Philadelphia, and I just had chemical cleaning, and as most or a lot of people do. And I had it in a tub, and it was a pristine tuba, silver plated, and it was only less than a year old, and it had this little scratch right in the first branch. And I'm like, oh no, I've done this thing, and I put the scratch in this brand new board, and these customers can kill me. And I started looking at it closer, and it was spider webbing, so it was actually traveling. And I'm like, oh, that's weird. I had seen it before, but not on such a new instrument. It was really kind of new. So I ended up calling the importer for the company. I won't say who it was, but they shipped me down another branch and said, no, it's faulty, that's under warranty. I installed it, the customer went on, and about 9 months later I had the same brand come in, also a new horn. It had a crack in the lead pipe just after the receiver. Same thing, the spider web crack. And I had a customer who was a saxophone player, and he was a metallurgist, or he's retired now. And he was more interested in the alloys of the saxophone. He wanted to kind of break down a Mark VI, but he was interested in what was happening and wanted to help me. And I told him the problems I was having. Is there a way that I can kind of stop this? And what is it that's happening? So that kind of led me on this journey into the molecular structure of brass, and it's really kind of interesting. So that's what I'll try to do today, and we'll talk about that. But to start off with, we've got different metals we use in the shop, and basically ferrous and non-ferrous. Ferrous has ferrite, iron, which is your tool steels and your low carbon steels. Low carbon steels you use probably like mandrels, that type of thing. They can only be case hardened. Okay, whereas tool steel, you can temper that in whatever level you need to. Go back to the UNS, which is the Unified Numbering System from the American Society for Testing Materials. They came up with this set of categories. So if you go to order metal from a supplier, they're going to want to know what alloy you want. You can't just order up and say I want brass or I want german silver. They're not going to know. They need to know more specific, like what it is you need. We add lead to some brasses to make them machinable, because if you were to do like regular sheet brass and try to cut threads on that, it's very brittle. It doesn't, it's not fun. So like 360 brass is what you would be using for machining. 260 brass is usually what you use for regular cartridge brass, which is what we use for horns, doing bells, making branches, necks, that type of thing. So, any others? Most of the brasses we're working with are anything above 70% copper. Once we get into the 80%, then we're into the red brasses or the gold brasses. You'll find just trying to get you through. Oh, sorry, I'm going to jump around a little bit. I'm going to go back to steels. We have another type of stainless steel that we're working with. And I don't know if you guys ever get Kraus springs, you know, when he came out with the stainless steel ones. And I had a magnet out one day and I was like, oh, I thought these were stainless, you know? And they're magnetic. And there's only one type of stainless that's non-magnetic. And there's 3 types of stainless steels. And what happens is in its austenitic stage, which is where the ferrite irons are all disheveled, they're kind of out of alignment, that's non-magnetic. After that, if you can actually work hard in that, and that'll kind of line up some of the irons, or you can heat that up and heat treat it, and those iron ferrite will kind of lock back in, and that's when they become magnetic. So we really have 2 types, and that's martensenic. So the stainless steel, the iron is in a soft stage, in an austenitic stage, and then once it goes through its process, or its hardening process, whatever that might be, you're bringing it to a martensenic stage. Then you've got a hardened steel. This is only in steels because it's only iron.
Isn't that also a way to determine if the steel is annealed or not?
Yeah.
Heat it up when it's not magnetic anymore or something like that?
I guess if you becomes magnetic, yeah, as opposed to austenitic would be its soft version, and martensenic would be its hardened state and magnetic state. So that's just kind of a touch. I'm not going to hang. Oh, also in the stainless steels, I think oftentimes you see like molybdenum, chromium, all of those chemicals that are elements that are added are creating carbon to give it strength. So that's the only reason that those are there. So I won't focus a lot on those because we don't make stainless steel instruments. Now the copper-based alloys, we usually have high brasses is what we work in, and that's high copper content. And bronzes, anything above 85% copper, usually it has tin added to it, but not necessarily all the time. There are alloys out now. When I started this whole thing, there was no Google. You know, it's amazing. Like Wikipedia must have started in 2004, right at that time, but there was no information. You know, and when I was asked by Bill to do the course, again, I was kind of hesitant because it was a lot of work to put together, and I remember it being kind of a stressful, thing in Boston. I was like, oh, I have all this information, it'd be kind of a shame not to share it with everyone. And I said, okay, sure. And then I checked out Google and Wikipedia, and I was like, oh my, it's all there. So you would not believe the amount of information that is out there, and pictures. And so I hope what this does is it kind of stirs you guys up into an interest in the things that you can do in your own shop and do a clinic someday yourselves. And also under copper-based alloys, you got brass, bronze, nickel brasses, which is our German silvers or nickel silvers. And that's generally, the ones we work with are 18% nickel added to brass. So we've got copper, zinc, and nickel content of some sort with some other trace elements. So anytime, and they are hard to find. You can buy them in sheet here, or from the States, but it's really hard to find bar stock. I got lucky and finally got.
There's one supplier in Germany who does it, but he doesn't ship out of Germany, so I guess it goes through the property.
Yeah, that's it. Oh, I got it from the States.
Yeah.
Bach has kind of a monopoly on it there, and one of my friends there knows one of the machinists, and I got some in cuts, so he sent me like 6 feet of 1 inch, so I could do, because you could cut in threads. Like I make removable lead pipes for trombones, and so we cut like a normal Bach, and then you want to put on a receiver. I was doing them out of brass because I didn't have German silver, but the threads, they become brittle and they cross thread, and whereas the German silver won't, it has a much better wearing, and it's just a great material to cut. It's fun.
Bitch to cars.
Yeah. Nickel sucks. I hate nickel. Speaking of the nickel, we got Monel valves. I'm sure everybody's dealt with those. And that's 67% nickel added to it with some other. So that's, but originally Monel was created to keep seawater from decomposing metal and salt. So that's why I think it was very useful in instruments for valves. I'm not sure what the Yamaloi version of that was, but that was their own kind of, Monel, I guess. Any questions there? That's kind of self-explanatory.
What used for the rocket plane, the X-15?
What is that?
Monel stuff, all these super alloys, nickel.
No, it's crazy, all
Crazy
this stuff that they have come up with.
So what's the other part of the composition
In Monel? Don't ask me that. I was, it actually had, I've actually got it. I'll look for it and I'll actually give you the composition. The metallurgist, who, my friend, I drove him nuts. I sent emails out constantly asking questions to the point that he stopped answering. I wanted to know what was happening, because I had this, Allentown man in Pennsylvania asked me to restore these fist horns, and they're from the 1860s, and I went up to take a look at them, and they were totally just disintegrating in the cabinets, and they were German silver, and I was like, I don't know what to do with these. So I went back to my metallurgist friend and I said, is there any way we can stabilize the metal at least enough to work with to get them back to a point? And he said, ideally the instrument would need to be taken apart. You'd have to put it in an oxidized coating, and then that would have to go into an annealing oven, and then we'd have to control the temperature just to get everything to kind of smooth out enough to work it. And it was just, no, that's not gonna. So I kind of walked away with that. Where was I going with that? Sorry, my brain, I had to go on joints. All right. Oh, silvers. Okay. There's two types of silvers we usually work with. Sterling silver, which is 925, which is 92.5% silver. There's others, 98.7. So you'll see different. So when you see the 925, that's what that means. Fine silvers, or pure silver, 99.9. There's always going to be a trace of something in there. We use that for plating. Primarily, it's too soft for making instruments out of. But you need a little bit of rigidity, a little bit of copper in there. So that kind of explains that. So if you see silver bells on saxophones or trumpets or whatever, that's some sort of sterling silver. So this is the fun part. Grain is amazing stuff. It's like there's a nucleus and the electrons bond to it in metal, okay? And what it does is it forms a dodecahedron, okay? And there's 12 bases on this thing. And the reason is they pack really tightly. And what happens is, am I jumping too far ahead? So they pack really tightly, and then what happens, you've got this, I'll start from the beginning. You've got copper, it's now turned to a liquid. You brought this to a melting temperature. You now add the zinc in. The zinc then dissolves into it, and it's kind of going through its forms, and it's now, all the elements are kind of traveling through each other. Now it's going to cool into a billet. And the billet, what it does, so we'll have a billet at this point, and that's the size of the grain, okay, of its initial. It's now going to go through a process of cold forming. However, we're going to do, we're going to draw a tube, we're going to hammer out something, and we're going to go through some cold forming. So they remain the same volume at this point. Now what's happening is you've got this dodecahedron. It's like a honeycomb if you turn it into a sphere, and it's got perfect edges on it, okay, and it's totally stable at this point. And now you're going through this stress, and all of a sudden those edges are becoming strained on the faces of that grain. So then what happens is you're under stress. And now I'm going to leave that there. Go back. There's a grain boundary that has also been formed at the same time. So all of these grains are sitting next to each other, but around them is this little electron boundary. And it has a lot of the impurities that, you know, might be a little trace elements of lead or tin or whatever it is. And they'll kind of migrate to those points. And that can be a good thing because it's going to allow slip to happen, which is grains will kind of slip over one another, and that's through that grain boundary. So as we're moving metal or stretching it, that's what's happening. So it's good for that. It's also good for, in the annealing process, what ends up happening is it kind of gives a fluid for each of the grains to redevelop into something else. Well, going back to that grain with those edges that are slightly, sorry, these aren't in order. Okay, so there's your grain. Straight edges, that thing is solid. It's not going anywhere. And as long as it remains in that, it will always remain that size. If all the faces are true, all the edges are even and totally straight, it'll remain there. As soon as you put it under stress of any sort, the edges start to bow. And at this point, right in the center of those arcs, that's when you start to get something called nucleation. And so when you're heating the metal up, now you're going to get this nucleation point. And, sorry, go back. Good, there we go. And all of a sudden what's happening at this point, this has been cold worked, and then at this point, each one of those little edges that have strain on them form a new nucleus. And then you've got electrons flying around, and they rebond and form a new grain. So now we've got all of this grain. So in one little area, centimeter square, maybe you had 10 grains, you know? After you've now heated the material up and it's renucleated, you might have 100 grains in that same spot. So what's happened is it's relieved itself. The grain boundary has kind of allowed it to renucleate in all of those points, and now you've got like 100 grains, okay? And as we hold that temperature for a longer period of time, like they'll usually put annealing ovens that they'll run for 24 hours or whatever. We can't do that in our shop, but I'll talk about that later, of what we can do. You'll start to get what they call grain growth. And what's happening at this point to this point is all of a sudden you've got some grains that are still perfect, that all the edges, they will remain the same. So they'll remain the same size all through the heating process because they don't have to change. There's nothing under stress. But the ones that are under stress, all of a sudden they start to overtake the ones next to them and they start to get larger. So you might have one that was a normal size and then one that took 5 over next to it. So you end up with this like strange pattern going on, which is what's happening here. As you hold the heat, this starts to happen and the grain is getting larger and larger. Anything beyond that, then you're starting to get into oxidizing the copper, and then you get into warp, and then you start eating through the metal and cause it. So stop there, don't go further. So that kind of.
So does that make it stronger when the grains are bigger?
Yeah.
Is there a stronger bond?
What happens when metal is work hardened, and it's it's under stress, as soon as you go to this area, there might be, it becomes harder as it gets towards the end of the grain growth. It's softer in this stage. And so when we stress anneal something, that's right before the point of recrystallization or nucleation. And so when we're heating something up to work it, the dent is not coming out, it's an older horn, and you're really having a rough time. That's what's happened. It's like, it's old, you're trying to move those massive crystals around, and they're just not wanting to go. And that's when you're gonna get it to crack through or problems, and there's a whole
That's why you
nother.
have to anneal it before you bake
Yeah.
it and then work hard. I heard when Kyle makes like saxophones with a silver bowl, they would anneal the silver much more often than the brass.
The
because it's
silver
work hard.
sucks.
Yeah, but I totally agree.
I thought it was gonna be the other way around. I got asked to make these Super 20 necks, you know, out of sterling silver. And I'm like, oh, silver will be
You have to
soft,
anneal
you
it all
know?
the time. You have to
Constantly.
work hard.
Yeah, it was really a pain. You know, I prefer brass way more. I wouldn't have thought that.
Yeah, it's interesting, you're on stage 3,
Yeah.
is when the renucleation starts.
Yeah.
What does that do to the metal?
What it does is it creates, okay, when I talk about grain growth,
Yeah, I mean,
I'm not
it's
meaning-
like these extra little grains,
Yeah.
that's right. But what does that do you think,
It
as
may-
far as acoustically?
oh, okay,
And just say if you actually heating it up,
right.
and you only get to that stage.
Well, this goes back to another clinic I was telling.
Let's talk cryogenic treatment.
Um, yeah, there's, yeah, maybe this will go on for, when the metallurgist friend who was helping me, he put me in touch with Maurice Fitzpatrick, who was dealing with Lawson. And so he was Lawson's right hand in figuring out the bells. Going back, this is just to deal with damping. And what damping is how quickly the sound wave dissolves into the material, okay? And Lawson wanted to control how the grain size on his bells. And it turned out to be really hard to do, because what happens is as you spin a bell, the throat is getting spun and then spun again and spun again closer to that flare. Okay, so by the time you get to the end, it may have only been spun a couple times, like in that flare, but that throat, it's gotten spun every time. So the more you work hardened it, the more stress has been created on all those grains, the higher the grain count is going to be in that area. And the lower the grain count is going to be at the end of the flare. So what he wanted to do was try to even that out.
Yeah.
And by, sometimes you'll see spot annealing in, you know, that might be advertised that way. People are trying to cause grain growth in that area without affecting the other.
So you're saying that you get renucleation
Yeah.
from cold forming as well?
No, that's only after you heat it in the annealing process. The cold forming causes more stress
Yes.
to create more nuclei.
Ah, I get it.
So you're
Yeah,
you're
yes.
actually increasing the number because of the cold forming.
I get it.
So now your grain count might be 120 at that throat, and it might be 10 out at the flare. So you're like, oh, how am I gonna like even this out, you know? And he couldn't do it. So it would have actually been better for him to probably with the material give it a designation by the highest temperature that the billet was made. You know, whatever the temperature that was the starting grain size of the material, and go from there. Now, how it affects damping, that's probably arguable. I think that's one of the big, I think, I mean, if you have larger grain, it's going to absorb less of the vibration, which will create it to go out further. And I think it would be a brighter overtone in my head, just trying to think of, because you look at like Monet, and then you look at makers that have big, hefty, and you tend to get a lot of, not sound, but vibration exiting the instrument is pretty forward, you know, as opposed to, it's not getting absorbed into the walls.
Still good projection.
Yeah, yeah, thank you. Yes. And so I guess from a damping point of view, that's what I think. So the more grain boundary you get, the more it's going to absorb vibration. So I think Lawson was trying to get that grain where it was work hardened to a larger grain size at that point.
So, you know what he's done now? Because he makes some really nice horns.
Yeah, he's passed away now.
What?
So yeah.
Just recently?
Yeah. So, but yeah, his wife had, she got really sick and passed away, and after that, he just kind of didn't. Yeah. No. He was an amazing guy. And then Bruce. Does anybody remember who bought Lawson out? And then he moved the factory up to like Connecticut or something like that. So he moved it. He had a great little factory in Maryland that was awesome. And yeah, no, sad, you know. But anyway, don't be sad. I'm not trying to. I learned a lot from him, and I'm glad that I can share what I did learn from him. So where are we with that?
So I suppose the less grains, the better the projection, because it absorbs less the energy from the...
That's what I think.
Because I mean, okay, it's totally unrelated, but Rolls-Royce does like turbine plates that are basically one big crystal.
Right.
I mean, the whole structure changes and it can cope with much more energy put through that turbine. I mean,
And that leads to the cryogenic treatment.
yeah.
Which Wayne Sanabi was dealing with a lot when I was doing this before, and I didn't believe that it affected brass like as much, because it's basically turning. It works with steel because it's transferring iron. You know, it's moving it through into larger. But now that we have Google, and you can actually find photos of their, of grain structure in growing. And they'll swear that it adds 10 years to an instrument.
Time will change it to bigger.
Time can change also. You've got age hardening, which is not the same as grain growth.
Yeah.
The only way you can change that is by heat. So the grain boundaries can actually harden and almost become like grain. So I think that that's more what it's doing. It's not reconfining it and then redistributing it, Whereas the theory with the cryogenics was that it was just kind of reduce something and then slowly let it come back into its natural state, and everything's relaxed and everything's back where it was in the beginning. It's a nice.
So is there probably on the boundary of the grains, is there like other elements that are kind of dissipating into the grain, something like that?
And the more you heat it,
it's like the oil between the grains disappears or evaporates, kind of thing.
They kind of overtake it. And if you think of the grains overtaking one another, it's more the grain boundary is actually moving and forming the grain from the outside. You know what I mean? So, and then there's a whole other thing that happens at that point called twinning. And I've been trying to read more about that, and it's like, whoa, I had to stop, And I was trying to prepare for the clinic, and I was like, I don't know everything, I don't know. And I was just like, so, but, yeah. Anyway. We could go over flame types. That's pretty easy. When we're annealing something in the shop, we don't have ovens, so we do have our torches. You do not want to use your oxidizing flame. It's gonna burn into your base metal if you're not careful. So you do want to use like a neutral flame and soft and bring it up slowly. And I generally will bring something up to red, but like a deep red for a stress relief, but not cherry red unless you really want to. And to get grain growth, oh sorry, those are some horrible ones. To get grain growth, you really need to hold it at a temperature, and with a flame, you're only going to be in one specific spot, so it's going to be on Okay, failures. Oh, there we are. Okay. This leads us to kind of the failures in the metal, what happens to the grain and the boundary. And one of those is stress, corrosion, cracking. And that's anytime a load is bearing on a surface, then what happens is the grains and the boundaries over time, they tend to like start to disintegrate and fall apart. And I'm sure we've seen old instruments that, you know, you've seen things get pushed in and you can almost see the grain structure left behind. So that's what that is. Season cracking. This one's interesting, and I think this one affects us more than any others that we could do to the metal. And one thing I really worry about is ammonia. And it's in brass, so, you know, it's like they sell it to clean up brass, and we're like exposing the grain and the boundaries to this ammonia. Ammonia is decomposing organic matter, which is what we're blowing through the horns anyway. And so that's when we're, so what ends up happening is it starts to attack the softest point, which is the grain boundary, and then it starts to separate. And that's when we have to be careful about it. So, you know, coming through repair, studying with different people, I've heard people recommend, I spray it with Windex after I've soldered, because it cleans it up. And yeah, the ammonia is great, it's just attacked the crap out of your metal, you know. So I would avoid using ammonia if you can. I usually use, the Miracle Cloth you could use, buffing, you could use there's a really good piece of literature written by James Moss. He's a clock conservator, and they do conservation on clocks from like Roman times on brass that has lasted that long. And he was having a problem because even in the teachings of them to clean and conserve, there's an ammonia solution. And what they were finding, they'd come back a couple of years later, and like the arms on these clocks were cracked. So they had actually caused the breakdown of the grains with these. So in my own shop, I have an old bell that I know I used Brasso on years ago, and I was looking at it the other day, and it's got little fractures right at the rim, and I swear that must be from what I was using, and that scares me. You know, we're going to lose these horns. So I think that needs to be brought up, and I think it needs to be, at least, there's a ton of information about ammonia cracking. There will be another thing, ammonia cracking, they call it ammonia crackers, and they like take ammonia, they turn it into a gas, then they cool it suddenly, and then it turns into nitrogen and hydrogen. Nitrogen is what you're having problems with the copper, but it's used for a whole other thing, it's for hardening steel. So keep looking for ammonia cracking on brass, and otherwise you'll just get separation of ammonia.
What do those cracks look like? Have they got a specific?
Yeah. This is the fun part. That.
Oh, right. That's hard to miss.
Yeah, that's a nice one there. I saw that and I was like, oh, I gotta have that one. I don't know. Yeah, so that would be a sample. This is, and I believe what happened, it's also age or season cracking. The reason they call it season cracking was because during the war, what happened, they had mortar shells and they were cold drawn at the top. And the ammunition was right next to the stables. I heard they were next to the bodies, but next to the stables, and the horse urine was ammonia, and it was very high, and it exposed these. So they're having all these crackings in these casings of these mortar shells, and that's why they call it season, because it was the wet season that they had come through, and that's how it ended up. But well, yeah, we have the same thing in our business, obviously. So,
I've got a friend who actually used to put his glass and trumpet in an ammonia bath.
Oh.
Just to get the right patina.
Oh. Yeah.
Yeah.
I would be interesting to see it now.
Yeah.
So and it keeps acting, you can't wipe it off, or is there a remedy that you can? neutralize it or whatever?
I think you can neutralize it, but just wash it well and make sure that. But this guy, James Moss, he argues that just wiping it with ammonia is enough to cause problems. But I think you can still neutralize and clean, wash that off. But just don't leave it on there. If you're going to use Brasso, please wipe it or wash it off well. So, oh, sorry. I'm seeing him on here, and I'm not sure that you're seeing him. That one's nasty. Actually, yeah.
What is that? Is it silver or?
No.
No, that's just deep brass.
Yeah, that's one of mine. Yeah, that's a great example of dezincification, and then the extreme of it. So that's a lead pipe, and what happens is you're blowing through decomposing organic matter or ammonia. It sets there, and then what happens is it forms a little solution with the copper and the zinc. And then as you blow through, the zinc is removed, and a new deposit of solution is left there, and it kind of goes through the cycle.
Is that what we call red rock?
Yep.
Yeah.
And what's left behind is the copper in that solution redeposits itself when it dries, and that's why it's pink, is because it's copper is red. So, and that's why we call it red rock.
That's a 50-year-old Barrington POS ring.
So that guy was drinking something acidic.
So that is just a result of that saliva.
Yeah,
sitting
that,
outside.
and it could be some stresses that remained, after it was formed. They maybe didn't anneal it, and so it retained that, and then with the, chemical.
There's also a detinning bath that I read it from saxophone makers when they throw the saxophone bodies after they soldered all the posts off. And they throw it in the detinning bath, and it's in there too long, it can create hair cracks on the end of bellows and stuff.
Right.
Like think soprano sax body, you have that bell here where there's a bit more tension here, and you get hairline cracks when it's too long in the detinning bath.
True. And there was a guy from Michigan, because the guy came to work for me, and he said, "Oh, there's an old fellow, and he uses one of these baths. It just removes all the solder." And I'm like, "Well, that's no good." Like it's He goes, "It was like magic." And I'm like, "Well, what's it doing to the base metal?" So I wonder if it might have been what he
Goes
was. So just take it easy. Is it ultrasonic guy? Yeah, I wonder what, I have an ultrasonic, and I use it, and I'm always kind of curious what it
There's
is
a
doing.
guy I was talking to in Holland. He makes period instruments,
Mhm.
and for some reason, he uses ultrasonic anymore because he's got a customer that he's done an experiment with him where he's ultrasonic some instruments and not others,
Mhm.
and this guy can pick the difference in sound.
Wow.
And he's worried about is the ultrasonic itself actually hardening the brass too much as well. And this guy, he's a pro player somewhere in Europe, and he will not touch an instrument that's been ultrasonic.
Wow. I have some people that don't want it to go through that. I run mine really low, because what I do find if I run it, I got the big 90-gallon, thing, and I would run it about 50%. I was trying to be kind of in the middle, and I was still finding on bare brass valves, it lifts the grain. I'll have a little bit of grain lift on it, and you get little sharp edges, and you've got to go back and burnish that back. And
Doesn't take much to strip the plate off a bar.
no, you got to be really careful. So now I run it down 20, and that seems all right. I've been okay with that. And I also keep your chemical solution kind of low, because it's just phosphoric acid diluted, and if you keep that low, so it's not attacking, because I think it's just going to help penetrate in. But the ultrasonic's great. I love it. But
It's powerful, it can shoot holes into aluminum.
yeah,
Yeah, interesting.
no, it's
Those direct uses.
yeah. So just be careful with them. And, yeah.
Brett, with the cleaning solution,
Yeah.
and when you do get a copper pinky sort of film,
Yep.
that's bad for the instrument as well, or not?
No, actually, that's a plating that's happening in that set. And what's happening is an electrolytic reaction of steel. So if you put a saxophone or something in there that's had steel,
Yeah.
it's now created this electrolytic, so it's taking the copper that's leached out and it's replating it onto the instrument. So that's why a new solution, you won't get that, but as time goes on, there's some copper that's leached out into it, and then it's plated back onto the instrument, so it's coming out pink.
And why would it be more profound on nickel as well, for some reason? Because if you have some nickel parts on it, it'll just, the nickel just goes straight to
Oh, so there's like a certain order of elements, order of metals. So you have
Yeah.
like lead and then nickel. I can't remember.
Does putting a lead block in the tank help?
30 years ago.
Put it what in the tank?
Putting a lead block in the tank?
You know, I've never done that.
That's what we did in Kansas.
Oh, okay.
We just hung a little lead block in the tank and it,
Were you at Wichita?
yes.
Do you know Craig Fuller? Oh, sorry.
But that's like,
I know Mark Madden.
Oh, okay, yeah.
That's
Everyone
exactly
knows
that,
Mark.
that order of metals, chemistry comes back. You have like a certain, I mean, that's why they have like, you hang your.
Antimony and
Yeah.
strontium and all that same words.
Often I put like a block of magnesium on the ship's hulls because the magnesium
Yeah.
goes away and the ship is full of
That's right.
Yeah, what's the zincs on the boats?
Yeah,
zinc anode, yeah.
To attract the
Zinc
salt,
anode.
so it doesn't crack. And naval brass will add arsenic, and that keeps the salt from breaking down the grain too, so, oh,
Yeah, in a lot of those marine environments, it's actually biofilms and sulfate-reducing bacteriums
oh, yeah.
in biofilms that are helping break that stuff down. And in our situation, that's definitely a potential.
Right.
Yeah, it's not just chemical; it's actually a biological mechanism.
Oh, right.
Yeah.
So, sorry, I keep staring at that. So the charting, we talked about that. Draw tempering, mostly used in acid and vertical cryogenic triggering, kind of covered all those topics. There's another example of red rot. That is stress, and I saw it happen. It wasn't good. Yeah. So what? Yeah. Luckily,
I've got another question. With red rot, then,
Yeah.
just more practical. If you notice it coming, have you got any methods to stop it and fix it?
I do. No, I don't.
All right.
If you clean it out, that'll
That'll help.
fix it, but it'll stop it from spreading further on.
Yeah, and I have annealed those areas,
Oh, yeah.
and that's kind of helped. But once it's starting to,
I think
It's
Maury-
like leaching out of it.
Morizani from Better Sounds, I think he actually silver solvents,
Yeah,
spots
yeah.
with silver solvents on
I have done, and then cadmium-free stuff is awesome. Like,
it. Yeah.
I know it's bad, but it flows really nice. So, or the cadmium, not the cadmium-free. Yeah, that would be really probably your only way of, and that would slightly anneal the area around it.
Yeah.
When you're doing it, so that would probably be the best solution. Sometimes it cracks like these, if you can re-anneal the area, and then have you guys ever seen saddle patches? They're like a U you put, you make a U out of brass,
Yeah.
and you lay it over the crack, and then wire it on, and then braze that, and then just cut off the bit, and then it actually gets down into the crease a little bit. So you could, to repair that, either that or you could lay a wire on it. You're gonna change the diameter, but I think this one's pretty messed up. Yeah, because I find that at those points where the grain is separated, it needs a new bond. Trying to bond those back it's gonna be a weak point again. So, let's see, quenching. Don't use acid, you don't need it. Like, just use water. I know a lot of people dip it in muriatic acid. Sometimes a flux, so if you're doing brazing, obviously it'll help in that situation, but you don't have to put it in like smoking hot, and besides that, the fumes are horrible for you. So water is fine. And when you are annealing and you quench something with steel, it's going to change. The grain's going to change by the cooling rate, and that's why you need to quench that. With brass, it's going to reach its point in its grain stabilization, and it's going to remain there whether you quench it or not. So it doesn't really matter with brass whether you're quenching or not after annealing. So just so you.
Is it true that you can harden brass to some extent by putting it in your oven for a certain amount of time at a certain temperature, or is that a...
Yeah, by getting grain growth to it, you could, create more grain growth, making it harder to work. So, yeah, usually they do like a 24-hour, Lawson had a big one that was out back that was pretty cool.
What's the temperature?
It's about 800 degrees, so...
Celsius or Fahrenheit?
Celsius, so yeah, I've got...
Oh, no, I meant Celsius or
yeah.
Fahrenheit.
I think
Never know.
I put some melting temperatures in the PDFs there, I think, but yeah. Where are we? Does this one get a 1?
You got about 15 extra minutes though, because everything started
Oh, okay.
kind of later,
All right.
so,
Cool.
yeah.
All right, so ask lots of questions, because I'm running out of material.
No, I saw that drawing of just the pictures that you had there. Some of them were quite interesting about the drawing plate and stuff.
Oh, yep. Well, I can move on to that, and then when we finish at the end, we'll just do lots of questions. Okay, this is my practical. We all have small shops, and this is the fun part. It's I couldn't bring all my equipment with, unfortunately, so I figured I would just show in pictures what I do in my shop. In this point, I use an arbor press. I also have a hydraulic press, which is this. And so if you can do pad cups, you can do guards, all kinds of fun stuff. But I find the arbor press really useful. This is nickel tubing here that I use off, you can buy it from Cervini or whatever, and I draw that down because I do a lot of trombone conversions. And Bach will sell you some things, but you can't get like outer slide tubes, so you have to make those. So I use tuba tubing, and then I anneal that, and then I draw those down through the presses. Now when you're doing that and you're drawing tubing, make sure you don't heat it up like bright red cherry hot. That thing's going to collapse on you. So you want to just do it dull red, and then use a lubricant, use a wax or some sort of burr life or something like that, and then that'll help with the drawing process. And then I take a measurement of the inside, and I know what I need to get to. I take a measurement of the outside, and then I just subtract by what I need to bring it down to. Sometimes you might have to open them up, but that'll get you, so I make my own outer slide tubes for the box that way.
Do you draw onto a mandrel through like a piece of lead or a copper disc?
Sometimes, yes, and I do that on the lathe. I didn't take any photos of that. I use my lathe as a draw bench, but after Bill brought in Red Wing Institute, they built their own draw bench. It's so cool. It was like under $100, and it's got like a winch, a boat winch, and they've got, it looks like mechanical, like kind of looking thing, and it's got a L plate at the end, and then he's just hooked up to the boat winch a screw in the end of a mandrel, and then he's bringing through an annealed bumper washer, just a steel washer you buy at the hardware store, but anneal it first because it's going to rip your metal.
I remember for a Schreiber when they made vocals, the Zoom vocals, they had like a long mandrel. They soldered up from 0.6 mils nickel silver sheet, and then they probably hammered the seam or whatever, and then they have this long mandrel, goes on the mandrel, and then they press it through like a copper disc, that thick 3 mil copper disc. And that disc is then reused by some other makers of like trumpets or whatever, so you can use this disc again. And I have a press like that, and what I did is I put it like on the corner of the bench, and then kind of put some pieces of steel I screwed that basically onto those 2 feet, and then so I can extend it, so I have a longer press range.
Right.
That works quite
Well,
well.
Lawson had a cool one that went. It was a hydraulic, so it would force through as opposed to pulling. And his went through. He had like a 2-story shop, and he had a hole in the floor, and it was on the side, and these long lead pipe mandrels, and they would just go up, and they would go through the floor, and then all of a sudden they would and would drive it up, and whoosh, and there was this lead pipe that was super long, and it was really cool. And he had all these different, because he had all these different theories of different tapers affecting, for whatever purpose, and he was a master at that. But so similar way. And then Shires, they'll do that too. They drive through the mandrel. But what I want to show you guys actually with mine, I don't use a mandrel. I don't make a mandrel for them. I do them a hollow, okay? And so let me. Well, before I show you that, these are some bending units. There's a Furries. I'm sure a lot of people have this one. Furries makes this. It's not a very good picture, but there's a bunch of different holes where you can move, and there's about 4 different blocks. I've made a bunch of different ones too. They're bending jigs, and so they're good for like lead pipes. If you have to make a lead pipe and you fill with pitch, and you can bend with that. And I'll talk about pitches too. This one is one I modified. It was just a cheapo one, I think about $300. And then I went ahead and I milled new holes in it so that the follow around had a roller that would follow the metal through. But this stuff here, that's jet set, or I think they call it morph. There's another name for it here. Oh shoot, something morph. I know I was carrying this through the airport, and it looks like but they're little pellets, and I'm sure you've seen it in other things. Some of you use it, but it's awesome. You just melt it in boiling water, and then you can put it around whatever. And if you've got a taper and it's straight, just run it around, and it'll take that form, and then let it cool, and then you can bend on it, and it will support the wall as you come around. This stuff is super strong. You can hammer into it. I use it for patches if you needed to do knuckles or something like that. It's great stuff. You can even use it on the hydraulic press with the urethane dies. So you can put it in there and that, or you can use rubber from old bike tire, rubber to put into the press. But you definitely need like a 20-ton jack to be pushing it in, so it's moving. It's got to be a good size. Pitch-wise, there's about 3 different kinds of pitch you're going to run into. There's red pitch, which is great for repoussé and chasing in metal, so you're working it from the back and the front. Then artists will use that. It's not good for bending. Don't use red pitch. There's also a jeweler's pitch, which is a little separate. It's kind of a gray color. I think one of these I had some in there. It's kind of a grayish green, and it's a little too soft, I'm finding. But the stuff that Allied has, they're black. It's definitely a good.
What is pitch?
Pitch, it's tar and asphalt. It's like mixed together in different ratios. And
Have you ever used Cerobend?
I have. And it's okay for small stuff, and if you've got light bends. I was just talking to Aaron Ebert, though, and I don't think I've been doing it correctly, because I kind of gave up on
I
it
think
early.
you need a certain temperature for the stuff, because it becomes brittle. Because it has this long, soft kind of state, and if it's too hot or too cold, it kind of just cracks.
Well, I think what happened was I wasn't quenching it, whereas he said you got to quench it, because what happens is the grain gets, so it's malleable, and freeze it, whereas I was just letting it air dry.
Yes.
And it's not brass, so, because I was thinking of it as brass.
So you fill the tube and then you quench it?
Quench it.
Ah.
And then it's still malleable. So I'm going to go home and try that now. Because I was having a problem with anything over a ½ inch. Anything over a ½ inch was snapping on me. It would
It just
snap
breaks and then you have to nice tape it.
Yeah, it sucks. So, Whereas the pitch at this point has been good for me. I don't know.
Are you still using blade?
Sometimes I don't. For some tighter turns, I have done that. But that leads on to, well, I had to do this tuba, this York thing. It was a conversion from a 3-valve upright to a 4-valve front with a 5th. And so, of course, the 3rd branch doesn't wrap all the way tight. It won't fit over the 4-valve section. So you had to make a new one. And I'm like, it doesn't exist. What am I going to do? So I make these out of flat sheet, and then, and that's where you don't have to use a mandrel. You can make saxophone necks, you can reproduce them. You don't have to like be drawing them through something, you know, and I lay them out, I take a measurement all the way through, just remember pi r squared, and remove the wall thickness, because otherwise you'd be like, why is it just slightly larger? You know, it'll make you nuts. So if you do that, your pattern is going to give you the taper you need, and you can actually almost do it on one of the allied mandrels, and I guarantee you'll be pretty much like smack on with your measurements. But I ended up doing a bunch of trial and errors with branches, and I got different bends. This wasn't good, and this one was really good playing wise, but my customer wasn't happy because he wanted that square so it matched, and I was like, so I had to take the whole thing apart again and redo, you know. So so there's that. The other thing is when you're doing these and you're making them out of flash, you can see I've got. So, well, this is me bending on this one. And that was when it was still warm. And yeah, I got some kinks in there, but they were enough to like burnish out. I mean, you're really lucky if you don't ever get some sort of little bubble. I think Jeff, I spoken to you, yeah. So, have you used that jet set before?
Not yet, no.
Oh, okay.
Just found out about it today.
Yeah.
Is that what's called wood's metal in the States?
No, I don't think so.
Quite commonly used for bending copper and brass.
I think so.
Wood's metal, brass metal, ferro bend, all the same.
So, yeah. Yeah, I think that's Ciro bend. Do you have Ciro bend?
No.
Okay.
I've been using low fusible alloys, but
Okay.
not successfully.
Have you guys ever used Ciro bend? Anybody else? No?
They use it in hospitals as well to create like custom coverage for x-rays.
Oh, that would make sense.
Ciro-
Ciro bend, for those of you that don't know, is pretty wild stuff. You just boil water, and it's metal, and you put it in, and all of a sudden it turns to liquid. It looks like mercury. It's really cool. And
It gets crazy when it cools down.
Yeah.
It's almost like you can push the parts of the alloy that are already hard in the
Into
parts of
it.
the alloy that are still soft. It's just strange. With your fingers.
it's so strange. I know, and this stuff I find fun too. And this one you can make teeth out of and all kinds of stuff. My daughter, she has a blast playing with it. This just melts in boiling water too. So when she comes to the shop, can I play with the jet set?
So how do you make the tube out of the sheet brass?
Yeah.
Hang
What,
it around metal or?
yeah. What I do. Let's see. I've got pictures of a lead pipe. Here we go. So this was a Hirschspringer lead pipe that was rotted out, and I didn't have time to order one. I had to make one. So that's my pattern that I'll make. And what I do is I take measurements every 200 thousandths, and then I subtract. So like on a saxophone neck, I'll measure every 200 thousandths, and then I subtract the wall thickness. Sometimes in areas, especially on one that's been used like this thing, or on some necks that have been pulled down, you're gonna get distortion in the bore. So I'll take a couple measurements, and then I'll take an average, because, you know, what are you gonna do? And then I'll come up with a number that I need to, then I plug that into an Excel file, and then it automatically reduces the wall thickness. And then it will give me what I need for here, and then I plot this out, and then I make myself a pattern. And it usually is pretty smack. I have a lot of failures, you know.
So what would be the next step? Do you have that cut out of brass and then you fold it over? Or how
Yeah,
do
so
you
then
get around
what
it?
I do-
Force soldering, that would be-
Okay, this isn't a great photo.
Especially with like a small diameter.
Well, you don't have to have a taper. Like I use a long trombone mandrel or a straight mandrel, and I'll cave it over just at the end. Like I just hammer it over, and it lines up nice. Once it's annealed, you know, it really lines up. It's like, wow, this is cool. You know, you do it, you guys will love it. It's great. And then you be careful though when you go to braze it. I use silver solder. Allied makes one that's coated, pre-coated. I think the Wolverine or something like that. It works well, but if you just buy from the jewelry supply, the silver solder, don't use Foscop, don't use. I've used all these other brazing rods; they'll snap on you. And it's like, you just like, did all this work, and but then, and then just be careful, because it should stay, the flux the outside really well, and then just follow it down with being liberal, but not too crazy. And yeah, it should stay, and try not to get it to flow into the inside.
Do you do that notches method?
I don't. I did. I tried a bunch of times, and I could not get. I didn't like the imperfections, and I couldn't get those hammered out. Especially for one-offs. If I was doing a production, I would, you know, maybe do that, and then I could roll them and have them hydraulically, you know. But for our uses, for when we need to do something in the little shop, I think that if we have to make a new tube or a taper, I think this is the best way for us to do it, and it's solid, because I mean I can bend these and have no cracking at all. Now when you are bending these, make sure that your seam is off at like a 45-degree angle. I don't like to bend on it. I think this is an example here of a failure. So you can see it just took too much pressure on it, and it's more likely, plus it was crappy pitch. And then it depends on temperature. Lawson always was like cold and quick. So if you're gonna use the pitch, he used to keep them in ice buckets and then pull them straight out and bend them that way. You know, I don't know.
So Brett, with the initial bending,
Yeah,
do you just do it by hand over the handle, or do you use a roller?
I do it by hand, and I use a.
Form it over with your hands.
Oh, I do. That's not a great picture. I'm sorry, I don't have a better.
So you just fold it over the mandrel like
Yeah.
like that with a hand, and then use like a roller to roll it kind of roundish.
What I do? So yeah, so just like I'll just call that the big. There's the center line of it, and I'll just take this little edge here. This is, okay, so first thing I do is I fold it in half. Like over the, put it on the edge of the table and you find the center point. Bend it in half with your hands. You don't want to peen it, you don't want to use rawhide or your hands, and you'll get it pretty square, you get an L. Then just, I collapse it over a rod, okay, any further than that. And then just take your rawhide mallet and start tapping down one side so you get a straight edge on one side, tap down the other side, and you'll be amazed. It just like kind of goes, ooh. And it wants to meet up, and you're like, oh, that's great. And then what I do is I wire it up at that point, and then I go ahead and I braid. It doesn't have to be a complete circle, just get those square and meeting. Then you can braze that line, and it keeps it nice and flat. You can wire it, you know, if you need to, so, and it'll flow nice. And then you can go back and do this. And I just put this on a straight mandrel, and then you can use a roller and whatnot. But you're gonna have to clean up some of the solder, you know, the brace that's you maybe got messy
So
with.
you solder it sometimes when it's like a V like that.
Yeah. So the top is
Like
kind
a
of
heart
like
shape almost.
yeah. And then it's gonna make it easier because now this is gonna be re-annealed at this point, so it's gonna move pretty easily for you. But again, try to keep it out of the inside as much as possible because that's a bear getting it out. So.
Do you spend a lot of time cleaning up the edges after the shear marks?
I do try to make them as clean as possible.
Yeah.
I've got a, I don't know if I, yeah, there's some, you can kind of see it down in the corner here. I've got a chop shear, and I usually do those, and that keeps it nice and clean. That's a horrible picture. Let me see if I have a better there. It's kind of down on the floor. And it's fairly deep throat, but it'll cut a nice straight line. But I usually use my, you can see them up in the top there, my shears, just by hand, the metal shears. And that gives me a straight edge. But yeah, I do go through, and because you don't want any, if you have like some little cut-offs in there, they'll kind of burn and throw you off. Because you want it as flat as possible when you get to that point.
I tend to, I mean, I did it only once, because I filed it flat, kind of hammered it a little bit.
Oh, after soldering?
No, before soldering.
Oh, before, yeah.
Just to get the corner.
Oh, definitely, yeah. You want to keep, because that inside, if you get that straight in the beginning, it's going to follow through and make your life much better. Because if you have any like, you know, that it's going to be like getting that out after you solder it. You know, so
Can you still anneal it after you still the solder?
you're going to need to, because you're going to have to work it again.
So you have to be careful that it doesn't, want too hot.
Yeah, so you kind of, because when you soldered it and brazed it, you annealed that area. So I would usually flip it over and I'll just do a big bushy flame. I've got a big wide like rosebud, and I'll do the back side of it, and that's usually is enough to work it and get it back around. But I will clean up the areas first, that, you know, as you said, the solder and whatnot. I usually use a sanding belt sander on that, just with a really fine grit, and then it takes that off and move on. So you can pretty much knock one of these out, you know, in 4 hours. So it's now the pitch. When we get to the next stage, that's a different. Where did I? So I'll knock it up and I'll plug up the end. I think this one I just wedged some cork or wood or something in there, and it's enough to stop it. And then this sets on the floor, and you pour it. I use an old coffee can. I just bent the edge of it, and I got some right angle pliers, and I grabbed the back of it, heat it up with a torch, and pour it in. It's messy, it stinks. Make sure you got a lot of ventilation, but that works. And then this one was bent on the freeze tool. I just did this one by hand. It's nice. It's kind of fun with the small stuff after doing the bigger stuff. It's like, oh yeah, this is easy. And then plated and installed. So that's kind of anyway. But yeah, so I'm at the end, unfortunately. Polymorph. That's the other word for this stuff. Jet set or polymorph. I think that's what they call it in Australia. So I just bought a bunch, and you can buy like tons of it for, you know, $20 or something on eBay. So definitely, like, it's easy to get.
Have you ever placed a stainless steel tube?
No, I don't want to. I can't imagine trying to correct the ovalness on that.
At the moment, I mean, I make parts for Irish bagpipes, and we have like a bass drum, we have like a really thin, small kind of tube bass. And normally we use brass 10 by 8, 8 mil inside, 10 mil outside. And I feel that usually the lead has still the best results, maybe.
Right.
But now I try like stainless steel, 0.9 mil volt thickness, because it's just lighter, much lighter, easier to get, because New Zealand is like a milk exporting country, so you can milk stainless steel tube, which is really nice on the inside, so there's no milk solids sitting there. And it's far easier to get than brass tubing.
Yeah.
So I started using milk tubes.
That's smart, yeah. Oh, well, maybe try the zero bin thing
But
now.
we've made it, it's fun.
Maybe try the zero bin and quench it.
I work with some silver in the meantime to relax.
Oh, that's over.
Yeah.
A little bit more about forming. Saxophone neck. This was in the last one. It's bright. Turn it to a darker picture. It doesn't help. Is it the thing? Sorry. It's a little better. Okay. They were asking me in the last class, it was Kurt was in here, and he said, because he's been doing neck projects, and I didn't know. I just was trying to figure out the best way I could make a neck without it going through a whole lot of working and a lot of bending. So what I do with these next is after I take the measurements and lay them out, I turn this into a pattern and cut it out. Let me see. So just like our straight tube that we made, but this one, oops, sorry, I don't want that. My drawing is terrible. I do that, and then I got a center point here, and then the same way, I go ahead and I bend the two halves together.
Atari.
Yeah. And yeah, so there you go. That's basically what that is. And then,
So you don't even have to bend it up.
no, it's already bent. The bin's built in. Now, calculating this bin, you don't want to make that thing. But yeah, calculating these is, you have to kind of like sit and then duplicate them on both sides a little bit. So your layout is the longest time, you know. But once you cut it, then what you can do is you make this a tube. It's already got your taper. You don't even have to make a mandrel for it. You can just do it on anything straight. And again, you braze it back to this point. Then you start to bring up this edge and you round it out as you can. Then you can brace both of those sides. And then you've got a bent tube to work with. You may have to work it out, put it through a drawing or so.
Better try on the fabric first, cut it on a fabric piece.
Yeah,
As a template.
that's true. I usually did a fairly hefty cardboard or like, you know.
Why
craft
don't you do a
paper.
bass clarinet bell? Because it's such a freaky shape.
I don't know.
Or saxophone bell.
I haven't been asked to do one of those.
So when you're making your pattern, you draw it out twice? So you draw
Yeah.
that side and then draw this side?
Yeah.
If you make a half pattern, much like they did in the
Well,
violin
that's what I
building?
do. I fold it over and so it duplicates. But the measurements I have to transfer, like, you know, I have to make sure that I've got them both. Yeah. But no, yeah, the butterflies. Yeah. So anyway, if you need to make a neck, you don't have a replacement, you can actually do this in not too much time, you know. And so hopefully with what you've learned today, it's funny, it's like what I didn't, this wasn't really, but this seemed to grab people. It wasn't really what I was trying to get across today, but I'm glad. So I think that's about all the information. Any other questions?
5 minutes or so.
Okay. No?
How many times can you anneal it?
Kind of infinitely.
Yeah.
Oh, things to be aware of. If you're on your soldering bench, okay, and all of a sudden you've been annealing and you picked up a little bit of lead solder from a previous thing. And have you ever had this happen? You've heated it up and all of a sudden, a hole right where the lead. Well, what happens is the lead has now entered into the grain of the metal and it's changed the alloy. You have a new alloy at that point.
Yeah.
And what it does is it lowers the melting temperature and now you've got a hole created because it's going to melt at a much lower, it might be below the annealing point of the material. So just be careful when you are annealing that you've got the lead, or if you're going to anneal a piece, get the lead off. Like, if I was going to re-anneal this, I have to get all this off, you know. Otherwise, I'm just going to eat right through it, and it's going to be it. So, just a warning. Yeah.
Been working with these silver sets and they love to quench in methylated spirits. And when you throw in like a hot, you know, like a really hot drink in methane, it does nothing. And then about 20 seconds into it, it bubbles like crazy and it stops.
Really?
And they say, no, only quenching methane. It's the other way it goes.
Yeah, no.
Yeah, I thought it was going to blow up.
Yeah.
I don't know.
I've had enough of work today.
I mean, wow. Yeah, no.
Parlor trick.
I'll have to try it.
You know, last time we were talking about stretching the crystals and whatnot.
Yeah.
I forgot to ask you, but the magnetic ink balls,
Yeah.
yeah, and you're going around. I don't usually actually like using them that much. So I was just wondering how, because it's so easy to blow it with magnetic ink ball, and it can, if you do it too much, it draws the pattern through. And
you mean with the magnets?
Yeah.
Oh, gotcha.
Yeah. How does that change? We were talking before about the crystalline structure, and if you look at that bend, so the internal bend of the crystal, they can be shorter, and they can get stretched on the outer bend.
Right.
How is that affecting the strength of the brass?
Well, I think again, just like your dent machine, or it's just, there's compressive and non-compressive, and I try to use as much non-compressive dent work as possible. I want to work it from the bottom or burnish it from the top. I try not. Last resort is you want to go mashing grains. So
I'll stop using the magnetic default pretty much.
There's moments like those damn Besson tubas with the punch-in, bottom blows.
Yeah.
But even then, you sometimes just gonna have to take the thing apart. And I'm trying to think. Again, on your lathe, if you're making stuff in your shop, I make with the hydraulic press, you can make pad cups, but what I've ended up doing now, like to remake pad cups for destroyed saxophones or whatever, I spin them. So I just take a Delrin stock, and it's kind of infinitely, you can turn it to whatever diameter you need it. Make sure that it's kind of, you don't want to cave it in on itself, but you want a slight bit of an angle. And you can spin, put that between your tailstock, and spin it, anneal it often. But that'll give you a beautiful pad cup, actually.
How do you do that? How do you do that?
Oh.
Cut a disc or?
I cut a disc out, and then I get it going, and then once you get it to a certain point over, then you can trim it out. But I take a cutter, a cutter with an insert. It's a long picture. It was basically a bar that I chucked up in my tool holder, and it's a polished, rounded end. And then I put some grease or wax on that, and then I just drive it in with my feed, and then get it in around the corner, and it'll make a beautiful edge on your pad cup. So cut
roller bearings, ball bearings there?
I don't have those. I would like to, because I got a spinning lathe now. I'm trying to do that next, and I will have roller bearings for those, because I think that's going to keep the friction down.
Yeah, I must have a handle with just a piece of steel with a little ball bearing screwed to the end and kind of.
Oh yeah.
I haven't done pad cups.
Yeah, it's just a different way. Because forever I was just doing them. I was using the hydraulic press, and then I was having to make all these dies and internal, and then it would get wedged in there, and I was like, and then I finally had this formula, and I was like, it's a pad cup. Hey, I've lost every bit of money, So I'm good at that. It's getting lost in these projects. So have fun.
As far as annealing goes, so I've only really worked with silver and annealing so jewellery, and you get sort of a light pink colour, I guess. Is it the same depending on the metal? Is it a different colour you want to get it to, or is it all sort of a similar?
It's going
to get to hold the colour as
It's
well.
going to be with the silver. You're also going to need to get it close to that cherry red.
Cherry red.
They make a temple sticks, they call them, and you can buy them from engineering supplies, and they're little sticks, and they're different chalks, and you can actually put them on the metal, and by the time you heat it, it turns a color, and that will tell you that you've gotten it to the annealing temperature. So,
how long do you have to hold that colour for?
just long enough to get to that point, that's it. Once you reach that temperature, the grain has changed to its point. Now, if you wanted grain growth or anything like that, you've got to continue to hold it, and it needs to be in a, but for stress relieving, and just, for stress relieving at this point, that's what you need, or renucleation.
What's that called? Stress chalk?
Temple sticks, I think. Yeah, that's what we used to call them. So I had them, and if you keep them around the shop forever, they kind of turn to dust and they fly apart. I was going to bring them, and I realized my box was just powder.
So it's some sort of crayon that kind of melts at a certain temperature.
Yeah, with a certain, that's exactly what it is. So it's whatever element just disintegrates at that temperature. So. Yeah. Of course. They say it's not too bad.
It has its effects. And something else about using not brass though, I use sometimes twinkle silver polish and twinkle brass polish. Have you ever used it on brass?
No.
Twinkle. It's like a cream, like smells a bit like, I have a suspicion of citric acid in it.
Okay.
But I find it works really nice on brass because it doesn't polish it really highly. It keeps it like that old. It looks still old, but it's clean. And
US they call it rights.
Oh, okay, yeah. I've seen
I got
that.
that from the US. It was Twinkle.
Yeah, but there's a different brand there still.
Is there?
Oh.
Yeah, it's exactly the same.
Okay.
It's on eBay. I mean, I had some old saxophones where I used that, and you see the crystal structure. And after cleaning it with that stuff, you still see the crystal structure. And
Oh, good.
that's why I quite like that stuff.
Yeah.
But I wasn't sure.
It's not too aggressive. Yeah, I don't
I
know.
don't think it
what's
has
going on.
ammonia in it. Definitely not.
This article that I told you about,
James Moss.
yeah, I have that here, and he actually goes into, he was using calcium carbonate, like
Yeah.
chalk dust, and mixing it into a solution that he was using to clean the parts with,
Yeah, that's what saxophone makers use to put it, I think, with a bit of oil and chalk
Oh, really?
between the posts.
And mineral spirits. So,
Yeah, that's what they use.
And then Stoddard's solvent is another one. It's pretty safe for brass.
There's one called, I think it's S80, have you heard of that one?
S80?
Yeah, it's
No.
clay based.
Oh, okay.
It's clay
Actually gonna write that down.
and the soap, I think a lot of Harley Davidson's in the guys.
Oh, okay.
It polishes everything up to chrome a bit,
Yeah.
but it's fairly duty.
That you mentioned that I remember hearing the term rotten stone. Is that something?
It comes in a tub and it's just mixed with water with a sponge.
Oh, okay.
But it's definitely clay based.
Oh, wow.
With a soap in it.
I can't remember where I heard the rotten stone for polishing and stuff, but I've never heard. I mean, I've never seen it.
I'll have to do a search on clay-based polishes. Okay.
Cool.
All right. Well, thank you, everyone. You can come up and see my failures if you like. There's a good book too on hydraulic diaphragm if you guys want to know further. Probably worth taking dives.
Those brain cells.
Yeah.